this one. So now this question, this one is what? This is summer 2022. So let's try and do this one. Let's go and see if there is organic. And not sure if we had done this. So this one. So he's saying suggest. He's saying sucrose reacts with water to form glucose and fructose in reaction A. So what you can see over here is this one. What you can see is water is being added, and when water is being added, the molecule breaks down into two pieces. So that is hydrolysis. Remember, whenever water is added and the molecule splits up, that's hydrolysis. And the next one is explain in detail why glucose and fructose are a pair of structural isomers. Your answer should refer specifically to these two molecules. So why are they structural isomers? The reason. Structural isomers. Structural isomers, remember there are two types of isomers. There is stereoisomers. Stereoisomers mein na wo aa jate hain, that's chiral and your cis trans, right? So he's not talking about stereoisomers, he's actually talking about structural isomers. So why are they structural isomers? So what do you think is the difference between the two? Structurally, what's the difference? Okay, what type of structural isomers are there? I mean, there are three types of structural isomers. There's a chain isomer or branch isomer.
Positional.
Okay, there's a positional isomer, and there is, now in positional isomer, you change the position of a certain group. And then you also have the third one, which is a functional group isomer. As a positional ka batao, what position has changed between the two molecules?
Sir, वो CH2OH का.
Okay, so CH2OH is one thing I can tell you is one of them is an aldehyde. I mean, let's talk about the difference. So he's saying refer specifically to these two molecules. So why are they isomers? One of them is that one of them is an aldehyde because the acetyl bond is right at the end of the chain. The other one is a ketone. So one of the differences is that glucose is an aldehyde while fructose is a ketone. ठीक है, फिर वो तुम्हारी बात भी ठीक है. They are I mean the OH group position. So what you can state is that one of them is a primary alcohol. So this one is a primary alcohol. And this one over here is a what type of alcohol is this? Carbon is bonded to two carbon chains. So that's a secondary alcohol, right? So you can say fructose is a secondary alcohol. While glucose is a primary alcohol. But anyways, that would still leave the answer incomplete because you have to explain what is a structural isomer. A structural isomer is, what is a structural isomer? They have the same number of atoms. So they have the same molecular formula. But they have different structural formulas. Or different arrangement of atoms, structural formula. So make sure you have to describe, I mean, definitely just to be on the safe side, you should describe why are they structural isomers? Because structural isomers, they have the same molecular formula, different structural formulas. And why are they isomers, structural isomers? Because of the difference in the structure. Is that clear?
Yes, sir.
Next is that's more mostly enthalpy change, so let's ignore that. So let's talk about this one. There's an unlabeled bottle containing a straight chain halogenoalkane Q. The molecular formula of Q is C6C5H11X, where X is a halogen, bromine, chlorine, or iodine. So that's one information. And it's straight chain. Okay, that's another information that's been provided. Okay, remember this is paper. This is summer 20 question paper 2-2. So anyways, what's the next? A test is carried out to identify the halogenoalkane present in Q. A sample of Q is added to NaOH and warmed. Then dilute nitric acid is then added, followed by a few drops of silver nitrate. A cream precipitate is observed. So the first thing is, when do you get a cream precipitate? And was added to NaOH and warmed, and dilute nitric acid is then?
Iodine.
As a cream precipitate, cream precipitate is not iodine, it's actually bromine. I'm sure we probably did this in halogenoalkanes. Just a second. If we haven't, I'll just add it. So halogenoalkanes were right over here, right? Yeah, actually we did do the reactivity, but I'll tell you the test for identifying halogenoalkanes. The test is, okay, you've got, so the test is, if you want to identify a halogenoalkane, remember this, that Cl-1, I mean, the test is pretty much the same. It's a standard test, which is you add silver nitrate followed by ammonia. So if you add aqueous silver nitrate, AgNO3, so that's the standard test. So if the solution has Cl- ions, it's going to give you white precipitate. So that gives you white precipitate. If it's Br-1, then you get a cream precipitate. So basically this one is bromine. What they are talking about is bromine. And the third one is if you do I-1, you're going to get a yellow precipitate. And the second part of the test is about solubility, that it dissolves in excess dilute ammonia. Dilute NH3. The next one, this one over here, the cream precipitate, it also dissolves, but dissolves in concentrated NH3. And the last one is insoluble in NH3, no matter how concentrated it is. So those are the three tests for identifying what halogen is present in the halogenoalkane. But anyways, the first part of the test was that when you have a halogenoalkane, he's hydrolyzing it. He said that there is bromine. If you add NaOH, aqueous, and reflux, what happens is that the OH ions from NaOH will knock out the Cl ions or the Br ions, and they're going to take place. The mechanism of the reaction was, we've studied the mechanism as well. Like for primary halogenoalkanes, it's Sn2 mechanism, which is that the OH ions would come in and the Cl will get pushed away, right? The OH ions would come in and the Cl-1 will get pushed away. Tertiary halogenoalkanes, the Cl would leave first, and then the OH ion would come in. So anyways, so this is what he's doing. He's adding NaOH aqueous and it's warmed. Suggests the identity of X, that's bromine. Okay, you clear? Is this clear? Yes or no? Is this clear? Alicia,
Yes,
clear?
sir.
Okay. Next one is write the Ionic equation. So this is what happens. If you add silver ions, the Br ions in solution will combine with it to form the cream precipitate, which is AgBr. So that is the solid insoluble precipitate. These are your aqueous ions. Describe a further test which would confirm the identity of X. So the further test, we just did that. I just told you that the further test was, okay, you're going to try and dissolve it in concentrated NH3. So the first further test is, the test is concentrated NH3, or you try to dissolve it. And the expected result is that the precipitate dissolves. It dissolves. Let's move on. The reaction Q with anyways tends to proceed via an Sn2 mechanism. So who proceeds via an Sn2 mechanism? That's a primary halogenoalkane. That's a primary halogenoalkane. What is the Sn2 mechanism? It's this one. Remember, there are three nucleophilic substitution reactions. Either the Cl is going to get knocked out by OH ions, or it's going to be knocked out by NH3, or it's going to be knocked out by Cn. Three different nucleophiles. And in all three cases, you kind of have the same mechanism, which is for primary halogenoalkanes, you have the Sn2 mechanism. The OH ion is going to come in, an intermediate, not an intermediate, but a transition state would happen. It's going to happen in one go. The OH ions will come in and the Cl will get knocked out, and that's about it. So suggest the formula of the straight chain halogenoalkane Q. So we figured out that it is a primary halogenoalkane, right? So we also know that it's bromine. So it's C5H11 and bromine, right? So the formula is C5H11 and Br. They've already previously told us that this is straight chain. It was written in the first description that it's a straight chain. That means all the carbon atoms, 5 of them, are in a straight line. Now, if I want to make it a primary halogenoalkane, where should the Br be positioned? Haji.
सर ये Sn2 mechanism क्या represent कर रहा है?
वो ये था ना Sn2 mechanism. It's a primary halogenoalkane. Sn2 mechanism किसका होता था? जब nucleophilic substitution होती थी, तो हमने क्या पढ़ा था? हमने ये पढ़ा था ना कि इसके halogenoalkanes have 3 substitution reactions, nucleophilic substitution reactions. The Cl will get knocked out by OH or NH2 or Cn. तो उसके mechanisms थे. Mechanism ये थे कि होता क्यों था? वो इसलिए होता था कि primary के case में it was this mechanism that the Cl and the carbon bond was polar. Carbon had a positive charge. The OH -1 with its lone pair was a nucleophile. It will get attracted to the positive carbon atom. वो करीब आता था और वो Cl टूट के साइड पे हो जाता था. ठीक है. तो हमें पता लगा कि Sn2 उसने word use किया. That means it's a primary halogenoalkane. Now, the next part is, where will you place the Br then? Is it on the first one, the second, third? If I want to make it a primary halogenoalkane, where should the Br be positioned? क्या होगा? What's the answer to that? Muneeb, any idea?
No, really, sir.
If I want to make it, what's a primary halogenoalkane? That's the question. What's a primary halogenoalkane? A primary
attached to one carbon chain only.
So the Cl would probably be at the end of the carbon chain, right?
Or this, yeah.
So, because if you want to make it a tertiary halogenoalkane, the Cl is probably somewhere in the middle of the carbon chain, right? Or even in a secondary, the Cl is somewhere in the middle of the carbon chain. But for it to be a primary, the Cl must be at the end of the carbon chain. So the Cl will be over here. So this would be H, and all of the other would also be BHs. So it's CH3, CH2. So the Cl is going to be over here. Explain why the reaction tends to proceed by an Sn2 mechanism rather than an Sn1 mechanism. So that's the next question. Now, the answer to that was also discussed. For tertiary halogenoalkanes, the mechanism is, which one? It's in tertiary halogenoalkanes. Tertiary halogenoalkanes, the Cl will break first, and a carbocation was formed. It was an intermediate, it was a two-step reaction, and then the OH-1 or any of the nucleophiles would come in and attach with this carbon atom. Now, the reason for that was, why do primary halogenoalkanes undergo Sn2 mechanisms? Because they have fewer electron-donating alkyl chains, hence the carbocation formed is unstable since it has a higher positive charge density. This is what we described. that forming the carbocation in a tertiary halogenoalkane is a lot easier. Why? Because if the Cl-1 leaves, the positive charge on this carbon is going to be smaller because it's surrounded by electrons, 27 electrons. So the carbon over here would be electron deficient, but it would not attract the electrons from Cl-1. It will allow the Cl-1 to leave. But over here, if the Cl-1 decides to leave, the carbon gets a positive charge. The positive charge would be very large. Why? Because it's not surrounded by a lot of electrons. So the positive charge would be very large and it will pull the Cl back again. It will not allow it to leave. So it would be very hard for the Cl to leave on its own. And the Cl bond, carbon Cl bond would be a lot stronger. So this is exactly what you're going to describe, that that there are fewer carbon chains around this carbon. Hence the carbocation formed has a higher positive charge density. This is what you're going to write. So primary carbocations are difficult to form, are very unstable. So they're very unstable. Why? Because they're fewer alkyl donating, so electron donating. Alkyl chains. And since there are fewer of them, electron donating alkyl chains, so the carbocation has higher charge density. So it's got higher charge density. So that's about it. So remember this main reason why you have an Sn2 and why you have an Sn1 mechanism. Is that clear? Also, is this clear? Rizwan, Umar, Murza, is this clear?
Yes, sir.
Okay. And make sure you remember this. Make sure, okay, I mean, this is a very important point, that it's easier to form tertiary carbocations. Why? Because if the Cl leaves, there's going to be less attraction between the two, because the positive charge over here would be very small. It's surrounded by electrons. So it will not pull, it will allow the Cl to leave. It will not pull that back because the positive charge is not very large. And over here, the positive charge would be much larger, because and that is why the Cl will not be able to leave.
So,
हाँ जी.
सर तो बेसिकली अल्काइल ग्रुप्स के ऊपर डिपेंड करता ना कि वो कितने हैं.
हाँ, क्योंकि अल्काइल चेन ज्यादा होगी ना, तो इलेक्ट्रॉन ज्यादा होंगे, तो पॉजिटिव चार्ज क्या हो जाएगा? कम हो जाएगा, क्योंकि उसको इलेक्ट्रॉन्स मिल जाएंगे ना. अगर एक बीच में पॉजिटिव चार्ज है और इर्द गिर्द ना यहाँ पे भी 9 इलेक्ट्रॉन्स पड़े, यहाँ भी 9 इलेक्ट्रॉन्स, यहाँ भी 9 इलेक्ट्रॉन्स, तो पॉजिटिव चार्ज का साइज क्या होगा? स्मॉल होगा ना, क्योंकि उसको इलेक्ट्रॉन्स और जगहों से मिल जाएंगे. ठीक है, हाँ जी.
सर तो लाइक इसकी रिएक्टिविटी लाइक इस क्वेश्चन से कैसे मतलब रिलेट करते हैं, आप प्लीज एक्सप्लेन कर सकते हैं?
नहीं, रिएक्टिविटी का तो लिंक ही कोई नहीं है, मैकेनिज्म का लिंक है. कि मुझे तो इन दोनों में से कौन सा कार्बोकाटायन बन सकता है? ये बन सकता है ना.
यस सर.
क्योंकि ये इसलिए बन सकता है कि इसको किसी दूसरे एटम के इलेक्ट्रॉन्स की जरूरत ही नहीं है, क्योंकि इसके तो इर्द गिर्द इतने इलेक्ट्रॉन्स हैं. मतलब समझ आइए कि अगर कार्बन होगा, उसके इर्द गिर्द CH3 and this carbon has a positive charge. इस पॉजिटिव चार्ज को ना इलेक्ट्रॉन्स ढूंढने का कोई मसला नहीं है. मतलब अगर यहाँ पे Cl-1 घूम रहा है या कोई भी घूम रहा है, ये उसके इलेक्ट्रॉन में इतना इंटरेस्टेड होगा ही नहीं, क्योंकि इसके तो इर्द गिर्द एनवायरनमेंट में हर तरफ देयर आर लॉट्स ऑफ इलेक्ट्रॉन्स. इधर भी 9 इलेक्ट्रॉन्स है, इधर भी 9 इलेक्ट्रॉन्स है, इधर भी 9 इलेक्ट्रॉन्स है, तो उसको तो हर जगह से इलेक्ट्रॉन्स, मतलब उसको अपने अंदर मॉलिक्यूल में से मिल जाएंगे इलेक्ट्रॉन्स. तो इसका मतलब है ये कार्बोकैटायन फॉर्म हो सकता है और ये बड़ा स्टेबल होगा, क्योंकि ये दूसरों के इलेक्ट्रॉन्स में इतना इंटरेस्टेड नहीं होगा. इसका पॉजिटिव चार्ज वुड बी वेरी स्मॉल. ठीक है, इसको कहीं और से इलेक्ट्रॉन ढूंढने की जरूरत नहीं है. इज दैट क्लियर?
यस.
तो टर्शियरी कार्बोकैटायंस आर वेरी स्टेबल. ठीक है, व्हाई? बिकॉज दे हैव मोर इलेक्ट्रॉन डोनेटिंग अल्काइल चेन्स. तो इसका मतलब है कि इट्स इजी टू फॉर्म देम. तो दिस इज व्हाट हैपेंस कि जब आपके पास टर्शियरी हैलोजेनो अल्केन होता है ना, तो उसके अंदर जब Cl अलग हो जाता है ना, छोड़ के चला जाता है, तो कार्बोकैटायन फॉर्म हो सकता है, उसको कोई मसला नहीं है, क्योंकि कार्बोकैटायन वुड बी इजीली फॉर्म्ड। इज दैट क्लियर? वो मतलब उस सीएल को जाने देगा, उस सीएल के इलेक्ट्रॉन्स को वापस नहीं खींचेगा, क्योंकि उसके इर्द गिर्द पहले ही इतने ज्यादा इलेक्ट्रॉन्स है, वो सीएल के इलेक्ट्रॉन्स में इतना ज्यादा इंटरेस्टेड भी नहीं था। ठीक है, इज दैट क्लियर?
Yes, sir.
उसके अंदर मसला है, प्राइमरी के अंदर यू हैव अ प्रॉब्लम कि इट्स वेरी हार्ड टू फॉर्म द कार्बोकैटायन। लाइक अगर प्राइमरी कार्बोकैटायन फॉर्म करता है ना, तो प्राइमरी के अंदर मसला है कि प्राइमरी के अंदर यू डोंट हैव कार्बन चेन्स, मतलब यहाँ पे 9 इलेक्ट्रॉन्स उसके इर्द गिर्द नहीं घूम रहे, देयर इज जस्ट एन H, देयर इज अनदर H। तो मसला ये है कि पॉजिटिव चार्ज, मतलब पॉजिटिव चार्ज बनेगा तो काफी बड़ा पॉजिटिव चार्ज होगा, क्योंकि उसके इर्द गिर्द तो इलेक्ट्रॉन्स नहीं है ना, तो वो Cl- के इलेक्ट्रॉन्स को वापस खींच लेगा, इट वोंट अलाउ द Cl टू गो अवे। तो वो कार्बोकैटायन अनस्टेबल होगा, इट वुड बी वेरी हार्ड टू फॉर्म इट, क्योंकि वो इमीडिएटली उसका पॉजिटिव चार्ज इतना ज्यादा होगा, इट विल अट्रैक्ट द Cl-1 बैक अगेन। इज दैट क्लियर?
Yes, sir.
So next one is the question. Okay, we're done with this. The next one is we've got two different halogenoalkanes P and R, both have the molecular formula C4H9Cl, are separately dissolved in ethanol and heated under reflux with NaOH. The major organic product of each of these reactions is methyl propene. Name the type of reaction occurring. So I'll just refer to the बल्कि उसी को refer कर लेते हैं. अच्छा, what happens when you have NaOH ethanolic? So halogenoalkane, you have NaOH ethanolic. What happens is elimination happens. कि एक जगह से ना Cl रिमूव हो जाएगा और दूसरी जगह से H रिमूव हो जाएगा. ठीक है, so there's this minor difference, which is that if you use NaOH ethanolic, you get elimination. The Cl and H get eliminated and you get a double bond in the middle. If you use NaOH aqueous, तो उस केस में you'll have a substitution. So in this question, he's using ethanolic. So he's using ethanolic. So and what he's saying is, okay, the type of reaction that's happening is elimination. And write an equation using the formula to represent the reaction. So you have C4H9Cl. उसमें elimination होगा, एक से Cl रिमूव होगा, दूसरे कार्बन से ना H रिमूव होगा, तो it will be C4H8, right? And plus HCl would be produced. ठीक है, this is what happens. An HCl molecule gets produced when you have elimination. On one carbon the Cl is removed and the neighboring carbon there's an H that is removed. The molecule में H और Cl कम हो जाता है. So we've written down the equation as well and draw the skeletal formula of methyl propene. So propene is 1, 2, 3. There's a double bond, propene, and methyl. Methyl means on the second one there's a methyl group, one carbon atom. And he's saying give the names of P and R. Now methyl propene was formed जब HCl remove हो चुका था. ठीक है. So what would be the molecule before this happened? मतलब that is easy. वो कह रहे कि original molecule बताओ. तो अगर alkene form हुआ था and he's asking for the original molecule, तो HCl को वापस add कर दो उसमें. ठीक है, you'll get the original molecule. So it's pretty simple, like you just reverse it. He's asking for the original molecule. So if this is the molecule, just add the H to the double bond, add the Cl back to the double bond. And that is exactly what we are going to do. Okay, I have this molecule. I'm just going to add. So I'm just going to add, balki isko na, let me draw methyl propene. So I've got 1, 2, 3 carbon atoms and there's a double bond, a carbon over here, और ये H है. This one has 3 H's. So remember, ये form हुआ था after elimination. This is 3 carbon atoms and 1 carbon atom in the middle. So it's this molecule. The original molecule figure out करना है, तो you just add H and Cl back again. So add the H over here, add the Cl over here, and the double bond between them will go away. It will turn into a And there would be two versions of this molecule. There's going to be another molecule where the H and Cl will probably present in a different arrangement. So starting point is the same. And you had a double bond. So this other molecule will have Cl over here, and it will have H over here. So you were saying there are two molecules, and both of those molecules, if you do elimination, both of these molecules, they result in the same thing. So you got this, and you have to name them. You don't have to draw them, you have to name them. So this is this is propane. So it's 3 carbon atoms, that's propane.
Sir,
हाँ
sir,
हाँ जी
सर इसमें मेजर और माइनर को मेंशन करना होगा.
नहीं ये मैं इसमें मेजर माइनर नहीं, उसने असल में ना क्वेश्चन उल्टा कहा था. मेजर माइनर होता है कि अगर मैं इसमें HCl ऐड कर रहा होता तो फिर मेरे पास दो प्रोडक्ट्स होते ना, या तो H इधर ऐड हो जाता, Cl इधर हो जाता, या Cl इधर होता, H उधर होता. ठीक है. तो मेजर माइनर जो है दैट इज बेस्ड ऑन कि अगर आप एडिशन कर रहे हो. ठीक है. वो मसला ये कि हम वो रिएक्शन उल्टी डायरेक्शन में आ रहा है. बात समझ आइए. मैं एक्चुअली HCl ऐड नहीं कर रहा था कि वो बन रहा है, उधर से मैं इधर आ रहा हूँ ना, तो वो कह रहा है कि वो ओरिजिनल चीज क्या थी. ठीक है. और उससे कहा था कि दो मॉलिक्यूल्स हैं जो ये चीज बनाते हैं. तो वन ऑफ देम इज कि Cl रिमूव होगा, H यहाँ से रिमूव होगा, डबल बॉन्ड आ जाएगा, सो इट विल फॉर्म दिस. The other one is Cl अगर यहाँ पे भी होता तो तब भी सेम होता कि Cl removed, H is removed, and the double bond would be over here. So anyways, one of them is 2-chloro, 2-methyl. So this one is 2-chloro, 2-methyl propane. And this one is 1-chloro, 2-methyl propane. ठीक है. तो एक में 1-chloro है, दूसरे में 2-chloro है. So that's your answer to this one. Now you have this one. The reaction shows how ethene can be converted into organic molecules. So C2H4, that is a simple alkene. ठीक है. So ये hydrogens है. First one, it's turning into an alcohol. So that's basically water being added. So remember, alkenes can you have. So alkenes have hydrogenation and it has hydration. Okay, 300 degrees centigrade, 60 atmosphere, H3PO4 catalyst. You add water, H and OH will get added. और उसमें major minor products होंगे. ठीक है. But in this case, it doesn't really matter. There's no major and minor products because it's a symmetric molecule. So what will happen is, okay, on one carbon atom, OH will be added, and on the other one, the double bond will go away. Okay, so there's going to be H and there's going to be OH. Most likely, he would be asking about the conditions. So conditions for reaction number 1 are 300 degrees centigrade temperature and phosphoric acid is the catalyst. And you have 60 atmosphere as the pressure. He's talking about reaction number 2. So what happens is the alcohol turns into an aldehyde. So what happens here? Alcohol turning into an aldehyde. What reaction is this? बल्कि साथ ही अगर मैं ये खोल लूं, इसके ऊपर तो लिखे हुए reactions. So where's the chart? ये वाला chart. So alcohol turning into aldehyde. How does that happen? That is oxidation. A primary alcohol will turn into an aldehyde if you reacted with KMnO4. And the aldehyde will get further oxidized to carboxylic acid. So if you want to stop at aldehydes, you distill. ये सारा हमने यहाँ पे किया था. I mean, somewhere over here we did this one. We talked about this in detail, that a primary alcohol will turn into an aldehyde and the aldehyde will turn into a carboxylic acid. And you're going to reflux. Nothing would be able to come out of it. So the reaction will not stop at an aldehyde, it will go all the way to carboxylic acids. But if you want to stop at aldehydes, so humne kya kaha tha, stop the reaction at aldehydes. Instead of heat with reflux, use distillation. That is what we stated. So if I want to stop at aldehydes, so this is what an aldehyde would look like. It will become double bond ONH. And there would be 3 H's. And if I want to stop here, I'm going to use K2Cr2O7. And I'm going to use it acidified and I'm going to distill so that the reaction stops at aldehydes. So the reaction number 5, what he's doing is the OH gets replaced by Cl. So how do you replace an OH with a Cl? So alcohol se halogenoalkane. So if you have an alcohol and the alcohol has an OH and you want to convert it into a halogenoalkane, the OH turns into a Cl. So these are all the conditions, like you can heat it with PCl5, PCl3 plus heat, HCl can be used, SOCl2 can be used. So there are different options. So the OH will be converted into or replaced by a Cl. So this one is PCl. Let's say PCl5 plus heat. हाँ जी.
सर ये तो नहीं किया था शायद.
इसमें मैं ऐड कर लेता हूँ कुछ रिएक्शंस ना इसी के अंदर ना, क्योंकि इसकी डिटेल भी इतनी इंपॉर्टेंट नहीं है. इट्स जस्ट दैट तो ये जो चार्ट बना हुआ है ना, इसकी मतलब कोई डिटेल फर्दर इंपॉर्टेंट नहीं है. मैं वो उसको वहां पे लिख देता हूँ, लेकिन इट्स नॉट दैट इंपॉर्टेंट. बीच में थोड़ा सा मैं हैलोजेनोअल्केन्स का ना थोड़ा सा कर लेता हूँ, क्योंकि we did do halogenoalkanes. तो एक सेकेंड, where's halogenoalkanes? ये था नहीं. You waited this one. So let's just add this. I'll just expand halogenoalkanes just to finish this off. So I'll add this to halogenoalkanes and their formation. So remember, formation of halogenoalkanes. Now for these reactions, the details are not important. It's not like nucleophilic substitution so the detail is really not important. And if you look at the sheet, formation of halogenoalkanes happens in a lot of ways. Like you can do free radical substitution of alkanes. This one, UV light, that would result in halogenoalkanes. Bromination of alkenes, reactions with HCl, HBr, and HI, that would also produce halogenoalkanes. तो पहले वाले तो आसान है कि it's a free radical substitution of, so that is free radical substitution of alkanes or any alkyl chains. We've learned the mechanism in detail, so I'm not going to discuss this now. Then it was electrophilic addition of alkenes. Of alkenes. And the third one is this one. It's nucleophilic substitution of alcohols. So nucleophilic substitution of alcohols. So I'll just talk about this one just a little bit. So when you have an alcohol, let's say you have OH. It can be the OH can be replaced by any halogen. It could become RX, where X could be, X could be Cl, it could be Br, or it could be I. So there are a number of reactions. Number one, you can either heat it with HX plus heat. So remember, X over here represents HCl, HBr, HI. So you can heat it with HCl, HBr, or HI. So the required halogen will displace the OH ion or substitute it. The second option is you can heat it with PCl3 or SOCl2 or PCl5 plus heat. The third one is red phosphorus plus Br2 or I2. Or you can have PBr3 plus heat as well. So you can also have PBr3 plus heat. And the fifth one is you can also use NABr plus concentrate H2SO4 and heat. Anyways, so there's a long list of reactions, and this is the summary. All you have to know is the alcohol OH will turn into or will get displaced by a halogen. And that's it. And another thing about halogenoalkanes is the uses, because remember, halogenoalkanes are kind of really useful. So the uses of halogenoalkanes, they're many. So some of the uses of halogenoalkanes is number one, they're used in CFCs, which are chlorofluoro. So it's chlorofluoro carbon. They use as CFCs. These are inert, volatile, and unreactive, low boiling point liquids. And they're used as refrigerants. You've studied CFCs in O levels as well. Refrigerants, you can use it as aerosols, as solvents. It's used in anesthesia. Chloroform is one example. So plenty of things. So it's a good replacement for water. Water is a very Water is an extremely reactive solvent. Like you can't use it in to fill things because things will rust with water. So you want something that is inert and volatile. But it is harmful for ozone. Another chlorine-related compound is PVC. You make PVC pipes and tiles and doors. Another one is bromine-related. Bromoalkanes are used often as fire retardants. So that's probably all the missing information that we have. That's pretty much sums up halogenoalkanes. You need to know the formation and 3 reactions. Make sure, try and practice questions instead of memorizing this. Try and practice question using this sheet. This stuff will get memorized if you practice a lot of questions and you keep going through this particular sheet. If you have a printout of this, then all of the reactions will probably get memorized. And these are the details, like you need these are the mechanisms of the reaction. For example, this one is this is the primary halogenoalkane reaction. This is the tertiary. So the 4 pages of mechanisms. So you have to remember 4 mechanisms and plus all of these reactions. Okay. So let's continue tomorrow then. ठीक है, कोई question तो नहीं है किसी का? Make sure you have a printout of this at least. ठीक है? हाँ जी.
सर तो जो आपने वो यूजेस बताए थे उसके लाइक ज्यादा सिग्निफिकेंस है उसकी?
नहीं, वो बस जनरली पता होना चाहिए. आपको पता होना चाहिए क्लोरो मतलब हैलोजेंस का यूज होते हैं. आपको पता होना चाहिए थोड़ा सा कि स्पेशली रिलेटेड टू हैलोजेनोअल्केन्स. CFCs पता है, मतलब CFCs you already know what is CFC is. ठीक है, तो वो आपको जनरली पता होना चाहिए उसको, क्योंकि डिटेल इंपॉर्टेंट नहीं है. ठीक है, मतलब वो फायर रिटार्डेंट्स के ऊपर एक क्वेश्चन आया था एक जमाने में ना कि वो 5 मॉलिक्यूल्स दिए हुए थे, व्हिच वन इज अ फायर रिटार्डेंट. ठीक है, लाइक इफ आई जस्ट गूगल फायर रिटार्डेंट्स, तो एक फायर रिटार्डेंट का ना एक वैसी ब्रोमिनेटेड फ्लेम रिटार्डेंट्स. ठीक है, तो उसके अंदर ना ये ब्रोमिनेटेड फ्लेम रिटार्डेंट्स होते हैं, विच पता नहीं अगर किसी का फॉर्मूला अगर है हमारे पास. जस्ट अ सेकेंड, 1 सेकेंड. ब्रोमिनेटेड पॉलीस्टाइरीन. ठीक है, वैसे ही गूगल कर लेते हैं, ब्रोमिनेटेड फायर रिटार्डेंट्स. इफ यू कैन हैव, हाँ ये देखो, ये इस तरह के ना वो मॉलिक्यूल्स. सो ब्रोमो एल्केन्स मैंने कहा था, या organic compounds with bromine in them, they use as fire retardants. ठीक है, is that clear?
यस.
तो ये बस वो एक क्वेश्चन आया हुआ था, उसने कहा था 4 मॉलिक्यूल में से कौन सा फायर रिटार्डेंट है ना, तो वो जिसमें ब्रोमीन होगा that's probably going to be a fire retardant. ठीक है, वो मॉलिक्यूल याद करने की जरूरत नहीं है because there are lots of, there's a huge variety of brominated fire retardants. ठीक है, so you can't even memorize one of them. ठीक है, तो वो बस आप आइडेंटिफाई कर लेना कि जिसमें ब्रोमो एल्केन होगा that's probably going to be a fire retardant. ठीक है, तो उनके ऊपर क्वेश्चंस जनरल से क्वेश्चंस होंगे, यूजर्स के ऊपर कोई इतना कोई स्पेसिफिक क्वेश्चन नहीं होगा. ठीक है, चलो ठीक है,
ओके
कल फिर करते हैं बात. ओके,
ओके सर.
अल्लाह हाफिज.
अल्लाह हाफिज.
अल्लाह हाफिज.